Welcome back, everybody. Pastic here, and I'm going to talk a little bit about the tangent theorem. So first thing we're going to do is set up the tangent of theta. That's going to equal a over b. I don't know why I put parentheses there. So I deleted them. So a over b. Tangent of the complementary angle, which would be 90 minus theta, is going to be b over a. Whoa. Sorry about that, y'all. So what you first can notice here is just kind of an interesting thing. It's that the tangent of one acute angle is going to be the reciprocal of the tangent of the other acute angle. My phone is ringing. I don't know what I just said last, but I got interrupted multiple times. So the tangent of one angle, one acute angle in a right triangle is going to equal the reciprocal of the tangent of the other acute angle. In more mathematical terms, it would look like this. The tangent of theta equals 1 over the tangent of 90 minus theta. So that is a connection that we have found. So that's part of the tangent theorem. It's kind of like a corollary, a side note to the tangent theorem. The most important part of the tangent theorem is coming up. So what some weird, goofy mathematicians did was they said, all right, let's take a look at the sine of theta, see what that equals. I don't know what that is. There we go. The sine of theta is going to be a over c. And they said, all right, let's take a look at what the cosine of theta is. And that's going to be b over c, if I'm not mistaken. And then they said, let's take a look at what tangent of theta is. It's going to be a over b, I would say. Okay, cool. Well, I said, well, how are these all connected? There's got to be something that connects the three of these, right? They're trigonometric ratios. They all apply to right triangles. They're going to apply to circles, as you will see. Pretty much anything that has a rotation, you can apply these to them. So they said, what happens if we do this? What happens if we take the sine of theta and we divide it by the cosine of theta? They said, all right, well, that's going to look like, let's see, a over c, right? A over c divided by, well, let's say b over c. Whoa, it's getting slow. B over c. Well, in order to do this, you have to remember how to divide fractions. And when you divide by a fraction, it's the same thing as multiplying by its reciprocal. So they said, all right, well, that's the same as a over c times c over b. And they're like, oh, that's kind of neat, because now what's going to happen here? The c's are going to cross out, and this is going to be equal to a over b. They're like, well, a over b, haven't we seen that somewhere? Oh, look at this, it's right here. Whoa, ho, 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 ho. So what they actually figured out was the main part of the tangent theorem, and that is this. The tangent of theta is indeed equal to the sine of theta divided by the cosine of theta. Another trigonometric identity that you're going to need to know and will be helpful if you do know. That's it for now. Take care, y'all.